Hi, this is Group 46, and today we're going to be talking about data streaming. Upon completion of this video, you should be able to identify what data streaming is, how data streaming works, why it's important, and lastly, what database tools and frameworks there are that you can use to store and stream data. Data streaming is a process used to query continuous streams or sequences of data. Instead of returning query results in large batches, conditions are quickly detected and data is continuously queried and returned in real time. Let's say you wanted to monitor weather in the GTA in real time using weather station IoT sensors. How do you analyze the real-time weather data? Even better, how do you know when a weather station is malfunctioning? What real businesses would do is first subscribe their application to all their IoT sensors so that every time the sensor collects a new piece of data, such as data on the temperature, humidity, etc., that data is sent over immediately to our streaming application. As a developer, you can then process the data however you want, whether it be parsing it or performing operations on the data collected, such as calculating averages, or in our case, identifying outlier temperature data collected by the IoT sensors. This will be the indicator we use to identify if an IoT sensor may be malfunctioning. Finally, once you've processed your sensor data, you can update your real-time dashboard and get real-time insights on the status of your sensors. As well, you can upload the data to your database for future analyzation and reporting. Streaming can get important and relevant information in real time, providing decision makers and professionals with valuable insights faster. These large streams of data, if queried and processed in batches, can be very large and difficult to store. Not only do organizations need to stop data collection at periods of time and process the data, they also need to aggregate the data across multiple batches. This process also ends up proving to be expensive, requiring much more hardware and processing power than data streaming. As a result, streaming makes it easier to handle, process, and aggregate data in small continuous batches, driving insights much faster, often within milliseconds to seconds from the initial trigger. With the growing use of IoT devices and sensors, as well as the development of big data, data streaming is quickly becoming a powerful tool business and professionals rely on. In a compositional engine, developers create a graph for the current condition before processing the data. This graph is also known as a directed acyclic graph. One of the most popular software tools that use this framework is the Apache Storm. Developers use declarative engines to process multiple streaming processing tasks at once. Declarative engines also construct the directed acyclic graph as it reads the data. Examples of the software that use this framework are the Apache Spark and Flink. Self-service engines are developing engines that help process data streams efficiently and quickly. Self-service engines not only manage the condition graph on their own, but also offer a service for storing the data into the database. For example, it organizes the data such that it can be easily analyzed to see if it meets future requirements. Currently, Upsolver is a known software tool to be using this engine. Now that you have finished this short lecture on data streaming, please pause the video and complete the following 3 questions. Thank you for watching our short video on data streaming.